Hi group, in this video we're going to take a look at how to set up your DAQ Assistant for the digital counter attached to your Hall effect sensor on your anemometer. So I'm assuming at this point you're pretty comfortable putting in a DAQ Assistant, and in this case we're going to acquire a counter, a digital counter input. And that's why you have to use a separate DAQ Assistant for this, because you can't do analog and digital tasks on the same DAQ Assistant. So I'm going to grab this edge counter, and for the hardware and LabVIEW setup I've got going, I only get the 9401 counters. So for yours, choose the 9401 counter 0. And at this point, it's pretty straightforward. There isn't much to select. So we have rising edges. That means it'll count every time the signal changes from 0 to on. And then we have our input terminal that should default correctly to the PFI 0. If you wanted to and you had your hardware set up, you could run this and watch the measured values increase. So that's all there is to this DAQ Assistant. And make sure you find that OK button to save this into your VI. It will most likely prompt you to add a loop. Most DAQ Assistants want to be inside a loop if it's one sample on demand. So I'm just going to click yes and let it nicely add that information for me. So the complication with this loop, however, is the output. So let's go ahead and set up our output, and maybe it'll be clearer what the complication is. I want to convert my bundle to an integer, and I'm going to choose the biggest integer available because the number of counts might get large, especially over a 72-hour period. We're going to get the stop sign out of the way. And as I put this in an indicator, this is going to be the total number of, if you double click on something, it shows you where it is in the front panel. This is going to be the total number of counts since the program started running. So the DAQ Assistant is just going to be hooked up to your Hall effect signal, and every time that Hall effect sensor switches from off to on, it will count that as a count, and it's just going to keep counting that forever until you tell it to stop. So you're going to have total counts here. So we have two challenges. The first challenge is I need to work out how many counts there were last time and subtract those out reliably. And the second challenge I have is that I need to know exactly how long a loop takes, because I want to know the counts per second. So it's not good enough to put a 1-second delay in this loop. I don't know how long the loop takes to operate. So if this loop takes 25 milliseconds to operate and I put in a 1000 millisecond delay, I'm taking 1025 milliseconds every loop. And over a long period of time, those start to add up. So instead, I want to set this up to be a precisely timed loop, and it's called a timed loop. And what it allows you to do is specify the period, or that is the time between the start of one iteration and the start of the next. So it precisely times the length of the entire loop, including the amount of time to check on the DAQ Assistant and do any math in here. And that whole time plus the delay is exactly 1000 milliseconds. So we know how long the loop took. And this is more precise than simply putting a delay in a while loop, which is what we need for our anemometer. One problem solved. The second problem is I need to take the total counts and reduce it by the total number of counts last time. So I'm going to go ahead and find a way to put in a feedback operator. So interestingly, if you put in a subtract operator and you wire the output to the input, you get this feedback node. And I want to then delete all the wires and just keep the feedback node. So at this point, I'm going to remind you, you have this context help. And so if you want more information about the timed loop, you can turn on your context help. And here, this is a feedback node, and it simply stores data from exactly one iteration before to the next. So I can take this feedback node, I can initialize it at the very beginning and move it one loop out. I can wire my data to this feedback node, and what I want to do is subtract last iteration's value from this iteration's value, and the quantity that is left is the counts this loop. So, so we end up with the counts this loop. We can set the number of seconds it takes for the loop to happen. And ultimately, I can know in the end how many counts per second are coming off of the anemometer. And assuming they are non-zero, I can use that calibration expression that we came up with using statistics to turn counts per second or hertz into miles per hour. That's going to happen most likely somewhere else. I'm going to use a local variable, and that came off your screen. So let's just, I'm just going to do it again. Control Z. Okay. Oh no. Oh, okay. Just disregard that. I was trying to show you create local variable here, and it fell off my screen, and then I hit a stray button. Okay, so here's your local variable. You would then be able to take this to any other loop. You can change it to read so that you can get the values out of it and turn that into counts per second or hertz, and then turn that into miles per hour or meters per second. So that should get you started. I think that's all you need for now, and ask questions as you have them.